In section 7, we're going to look at solving equations that have inequalities. You can tell it's an inequality because it has symbols like this, which is less than, or greater than, or less than or equal to with a line underneath, or greater than or equal to with the, again, line underneath. Interval notation is where you can make your answer. It can, this would be like set notation. So this is all x such that x is greater than 3. On the other hand, that could also be written this way. This is what interval notation is. So it's got parenthesis 3, comma, infinity. So note, this would be all the numbers that are above 3. If it had greater than or equal to, then I would have a bracket in front of the 3 instead of a question, instead of a parentheses. So parentheses are for greater than or less than. Brackets are for greater than or equal to or less than or equal to. When graphing a inequality, we're going to use the interval notation style, which is if we have a parenthesis for, in this case, this would be less than 5. So parentheses at the 5 and then an arrow to the left. Here we use a bracket because we have greater than or equal to the negative 3. And so again, a bracket at the negative 3 and then an arrow to the right. Now, perhaps once long ago, we used open and closed circles to say the same thing. In other words, we would put an open circle here for greater than, and we'd put a closed circle or an open circle that's filled to do greater than or less than or equal to. A compound inequality is one in which you have two different inequalities going on. For example, you could have x is less than or equal to negative 3, or x is greater than or equal to 2. And so because of that or, we're going to actually do the union of these two. And so the little union symbol there. And so you can see how parenthesis, arrow to the left for less than the negative 3, and here bracket, and then arrow to the right for greater than or equal to the 2. Over here, we have an and instead of an or. So x is greater than or equal to negative 4, and x is less than 4. And so it's going to be everything inside of here. Note, it's not going to include these because the and means both of them have to be true at the same time. Turn the u upside down. Looks kind of like an n. That is for the intersection of these two items. A little bit easier way of writing an intersection is this way. X is greater than or equal to the negative 4 and less than 4. Now, when you have a greater than or less than that goes with a quadratic, in other words, like this, ax squared plus bx plus c is less than 0, could be also greater than 0. In other words, any of these symbols would make it an inequality. Solving the quadratic inequality involves first solving the quadratic equation as if it was an equal sign, as if there wasn't an inequality. That allows us to identify which intervals to check. And usually what's going to happen, and you'll see an example later on, it's going to be kind of an inside or outside kind of thing. In other words, our intervals will give us something that may be over to the left or over to the right or in between kind of things. And generally what tends to happen is either the outside ones tend to work or the inside one tends to work. But we'll see an example of that shortly. Rational inequalities can be described in a similar fashion to the quadratic. First, we rewrite the inequality so that 0 is on one side and a single fraction is on the other side. To determine the values that will make either the numerator or denominator equal 0, these values determine the intervals to be tested. So note here we have 5 over x plus 4 is greater than or equal to 1. So we move the 1 over so that now we have just 0 on the right. 1, of course, can be rewritten as anything divided by itself. We need the common denominator here. So putting all that together, we now have 1 minus x over x plus 4 is greater than or equal to 0. Setting the numerator to 0, 1 minus x, will give us an x equals 1. And so that becomes one of our boundaries. And setting x equal to negative 4 would create our other boundary. And so we have 3 intervals to check. From negative infinity to negative 4, negative 4, 1, and 1 to infinity. And again, tends to be an inside-outside kind of thing. Now, one last note before we look at some examples. Please note that x cannot be 4 since the denominator cannot equal 0. So in other words, cannot be negative 4 because that would make negative 4 and 4, that would be 0. Of these, only the middle interval from the forms the solution. Also note that multiplying both sides by the equation by x plus 4 requires considering 2 cases because the inequality sign must be reversed when this is negative. The above procedure does not require that extra consideration. All right, so a lot of information there. Let's look at a few examples. So first off, we have 3x minus 6 is less than negative 9, or 3x minus 6 is greater than or 9. So we're going to go ahead and solve these. So move the 6 over, so 3x is less than negative 3, or 3x is greater than 15. Divide both sides by 3, and so x is less than negative 1, or x is greater than 5. Note how I just solved both of them as if I was doing each one individually. All right, now the main thing is I have no numbers, so, somewhere appropriate. Okay, there's 0. And so that means that has to be negative 1, and 1, 2, 3, 4, 5, that has to be where the 5 goes. I have no lines underneath, so I will use parentheses. 1 here, 1 there, and then that's my arrow to the left, and that's my arrow to the right. Please note that I used the little kind of curly line there instead of just a straight line, because especially when you have black pencil on black lines, that can be hard to see. Now, in terms of interval notation, this one would be from negative infinity to negative 1, and then the union with 5 to positive infinity. Again, since I have no lines underneath, I have no or equal to, and of course we can never equal infinity, so those always get parentheses. But one of the nice things about the interval notation is it's matching. So here I have a parenthesis, here I have a parenthesis. Same here and here. So the interval notation and the way I graphed it match. All right, in part B here, I have 3 parts. But I'm going to do the same thing to all of them. So first, I'm going to add 10 to all 3 sides. Now I'm going to divide all three parts by 4. And again, the important thing is, since I have no numbers, is just make sure I can get everything on the graph. So for instance, if I say that's 10, 9, 8, 7, 11, 12, 13, 14, 15, I got lines underneath, so I'm going to use brackets. And I want things in between. So 7 is, or x is greater than the 7, so I'm pointed that way. X is less than the 15, so again pointed that way, and then I'm going to make my line so it's very obvious that I'm talking about in there. And my interval notation, bracket 7, 15, bracket, 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 and so forth. There is part B. All right, C. Now I have equations on both sides, so I'm going to go ahead and solve. So if I move the 6x over, I have negative 10x less than or equal to, move the negative 7 over, so it becomes positive 7, so 13 and 7 is 20. Divide both sides by the negative 10, and over here I'm going to have negative 2, but because I either multiply or divide, in this case divide by a negative number, I have to flip the inequality. So again, pick some spot. Here's my 0, which means there's my negative 2. This has an equals, a line underneath, so it's or equal to, and my arrow is going to go that way. All right, let's look at some quadratics. So again, first we're going to solve it as if it had an equal sign. So we're going to go x squared minus 7x plus 10 equals 0, which leads to x subtract 5, x subtract 2 equals 0. So that means then my two solutions would be 5 and 2. So that means the intervals that I'm going to check will be from negative infinity to 2. It'll be from 2 to 5. And then it's going to be from 5 to positive infinity. So let's go ahead and check. Now, to do this, to do a check, I just need to pick a number that's in each one of those intervals. Pick numbers that are easy. For instance, between negative infinity and 2, let's try 0. So 0 squared, subtract 7 times 0 plus 10. Is that greater than 0? Okay, it is. So that worked. All right, next. Let's try between 2 and 5. Let's try 3. So is 3 squared minus 7 times 3 plus 10 greater than 0? Well, this is 9. So 9 subtract 21 is negative 12 plus 10. That's going to be negative, so no. And then something that's above 5, for instance, we could do 10. So 10 squared, subtract 10 times, or 7 times 10, plus 10. So it's basically 100, subtract 70, which is 30. 30 plus 10 is greater than 0, so that one worked too. So that means the parts that I'm going to shade, if you will, or outline, have to be for the interval that's negative infinity to 2, and the interval that's 5 to infinity. So again, let's pick a 0. Say this is 0. So 1, 2, 3, 4, 5. So one parenthesis here, one parenthesis there. There's one arrow. There's the other arrow. And in terms of interval notation, let's see, I'll do that up here. We're going to have negative infinity to 2 union with 5 to positive infinity. And that will be my interval notation for the answer. All right, here we need to move the 4 over so that we would have 3x squared plus x subtract 4. And then again, we're going to act like it's an equal sign. This one will factor into 3x plus 4. Now, please note, these are not always factorable. I've just given you some examples that were. And so these will solve into negative 3/4 and x is 1. So that means our intervals are negative infinity, negative 3/4, negative 3/4 to 1, and the last one would be 1 to positive infinity. Now, since these ones have a bar underneath, it actually should be a bracket there, brackets here, and then a bracket there, because we have an or equal to. All right, so now do our check. So between negative infinity and negative 3/4, let's do, say, negative 2. So we're going to have 3 times negative 2 squared plus a negative 2, subtract 4. Is that in fact less than or equal to 0? It doesn't matter if I do this right here or I do it with the 4 moved over to the other side. Now this part, of course, will be negative 2 squared, so positive 4. 3 times 4 is 12. 12 minus 2, 10. 10 minus 4, 6. 6 is not less than 0, so no. And between negative 3/4 and 1, since one's negative and the other one's positive, let's just do 0. So 3 times 0 squared plus 0, subtract 4. Is that less than or equal to 0? Well, 0, 0, subtract 4. Yeah, that will work. And then for something that's greater than the 1, we can do a positive 2. And here, that's again 12, but now it's plus 2, so 14 minus 4 is 10, which is not less than 0, so that one's a no. So only the middle portion is going to work. And so we could put the 0 right here. And so this is 2, and this is negative 2. Now that I have that backwards, this should be a 4/3 instead of a 3/4. A little bit ahead of myself there. Still negative, but it should be that. So negative 4/3 is a little bit more than negative 1. So we're going to be going in here about a third of the way. And then positive 1 would be over here. And then the line in between. So on the outside, which we often have with the greater thans, and then on the inside, which we often have with the less thans. All right, in our third case, let's see, this doesn't seem to be factorable, so let's try to do quadratic formula. So x will equal negative 3 plus or minus the square root of 3 squared, 9, minus 4 times 1, which is 16. over 8. 4a, a is 4, 2 times a. Now, please note this is going to give me negative 3 plus or minus I times the square root of 7. If you're like, why the I? Well, 9 minus 16 will be a negative number. Square root of negative makes that I, since we have imaginary as part of this answer, here it's a no solution, or I should say no real solution. So not every quadratic will give us something we can graph, will give us a real solution. All right, a couple of quick examples with the fractions. So in this particular case, set 6 minus x equal to 0. So of course x is 6. X plus 2 equal to 0 leads to x equals negative 2. So my intervals are going to be from negative infinity to negative 2, 2 to 6, or negative 2, excuse me, and then 6 to positive infinity. So now we can check. So from negative infinity to negative 2, we could do like negative 3. So that would be a 6 subtract negative 3 over a negative 3 plus 2. Is that greater than 0? Now the top is going to give me positive 6 plus 3, but the bottom is going to give me negative 3 plus 2, so this is a no. All right, now let's try something in between negative 2 and 6, so we can try 0. 6 minus 0 over 0 plus 2. Is that greater than 0? Okay, again, numerator is going to be positive, denominator is going to be positive, so that will be greater than 0, so that one works. And it turns out if we went ahead and did it, the last interval would not work either, because the top part is going to give me 6, if we pick like 8, for instance, it'll give me 6 subtract 8, which would be negative, but the bottom would be 8 plus 2, which would be positive, which means the whole thing would be negative, which is not greater than 0. So in this case, I can pick something like, say, here. And that's for the negative 2. So that's 0. That's 6. And so that one's going to have 1 in the middle. So no, even though we had a greater than, it still ended up in the middle for what was going to work. All right. This last one takes a bit of work, so I'm going to do it on a separate piece of paper. So first off, if we want to have everything on one side, then we need to make things so that I can have a common denominator. So the first one, I'm going to do x plus 3 and x plus 3. The second one, I'm going to do x plus 1 over x plus 1. Now I can combine the tops which is going to give me, let's see, 4x plus 12, subtract 2x minus 2, all over x plus 1, and x plus 3, and combining my terms, I'm going to have 2x plus 10, x plus 1, x plus 3, which for the numerator, that will lead to basically x equals negative 5, and then the two denominator ones, so x equals negative 1, and this one, x equals negative 3. So what that means is I'm going to end up not with 3, but 4 different intervals. My intervals will be from negative infinity to negative 5, negative 5 to negative 3, negative 3 to negative 1, and then the negative 1 to positive. Now, similar to the process we've done before, I won't go ahead and write down checking them all, but the bottom line is the only ones that are going to work are that one and this one. And so, final answer will have this. And in terms of the graph, and put it, say, 0 here, so -1, 2, -3, -5. And so we're going to end up with, between these two, and then that for the last one. All right, our last example with a projectile motion type problem. And the question is, for what period of time is the projectile at least 744 feet above the ground? So that at least tells us that we're going to have an inequality. So again, our equation is this. So the 744 will be with the S. Rearranging, it'll look like this. At least greater than or equal to 744. So we'll move everything to one side. Plus the 220t, subtract 744, greater than or equal to 0. So we always want to set it so it's greater than or less than to 0. Now we're going to take the case as if this equaled 0 and go ahead and solve. I can divide everybody by, in this particular case, you wouldn't know that necessarily. You might have to work it out, use a factor tree, for instance. But it turns out that I can factor out a -4, and I'll end up with a 4t squared minus 55t and plus 186. Now, you can do Pythagorean, or excuse me, you can do quadratic formula. It does turn out this factors, But, you know, it's not an easy one to work out by trial and error. So you could do it by the quadratic. And so 4t minus 3 equals 0, t minus 6 equals 0. Here the t will end up being 31 over 4, and here the t will end up being 6. Now, by the way, if I'd wanted to do a quadratic, I would have set it up this way. And so then the t would have equaled 55 plus or minus the square root of 3025, which is the 55 squared, minus 2976, which is 4 times the 186, all over 8, 2 times the 4. And it turns out that becomes 55 plus or minus 49, which is 55 plus or minus 7. And 55 subtract the 7 will be 48. 48 over 8, there's my 6. 55 plus the 7 will be 62 over 8, which is 31 over 4. Now, my intervals in this case will be negative infinity to 6, and then I'll have 6 to 7 3/4, and then 7 3/4. Oops, got an extra line there. 7 3/4 to positive infinity. So this one's from negative infinity to 6, so it's really easy to do the 0 case. Negative 16 times 0 squared plus 220 times 0 minus 744. Is that greater than or equal to 0? Well, this is 0, this is 0, that's negative, so that's no. So we can see that that didn't work. Let's say I tried in this interval and I just picked 7. So that would be negative 16 times 7 squared plus 220 times 7, subtract 744. Is that greater than or equal to 0? Well, these combined, let's see, what are we going to have? So, let's see, the one's 49 times 16. So this is negative 784 plus 220 times 7. That's 1540. Subtract 744. So let's see. Subtract 4, subtract 4. And it turns out we get 12. So that one does work. Check. So our answer then will only be that part. In other words, between 6 and 7 3/4 seconds will the projectile be at least 744 feet above the ground. And so examples of really all the kind of problems that we've had up to this point in the chapter, but with inequality.